All right, so here's Lava Lamp project. This is, well, the start of it. I don't have any water in it yet. And the first, instructions, Emma. Thank you. But first step is to pour 1/4 of water into the cup, bottom of the jar with 1/4 of a cup full. So put that in there first for substance or heterogeneous substance. Then next we have add vegetable oil, fill the bottle leaving up to 1 inch in a mason jar, fill the lip. So we don't have a mason jar, we have a cup here, so I'm going to open this real quick. And fill this all the way up here. I'm adding another homogeneous, I don't know if it's a substance or a solution, but should be it. All right, so that's how much I got for that. So we're gonna leave it that as that. Then, next we are going to add food coloring, which is going to be a physical, oh, here, could you hold that? Keep your button on that, keep your finger on that. Hold the finger.
Okay.
And we are going to be putting a physical change within this, or just physical change. You're gonna put 1 drop, 2 drop. Yeah, I'll just put a couple drops in there for sure. How many drops did it say on your phone?
It said just a few.
Oh, I guess that's a few. Okay. Now, next step, we are going to watch the food colors drop through the oil, rest on top of the water before slowly starting to mix with the water. Okay. So I see that in here, and this is probably a, well, I wouldn't know if this is a physical or a chemical reaction. And so they've reached the bottom, and I don't know. I think that's like more of a physical thing that they got to the bottom, not more of a chemical thing. Here, something I might know a bit more. Okay. Add a teaspoon of Alka-Seltzer in your tablet form. Add the tablets. So here, I know this process pretty well. This one is the most straightforward. So going in, this is a physical change. The Alka-Seltzer tablets are going to drop in there and start fizzing. Well, there goes the fizz. I see them coming up. And as soon as the Alka-Seltzer dissolves, that is a physical change. But we also have a chemical change as well, which is the bubbling you see from the Alka-Seltzer. Another thing that is relevant within this project. Now, we're still recording, good. Now, the bubbles are rising to the top, and I'm gonna make sure every single one gets there, if I can. Here. You see the bubbles right there. They're rising, the Alka-Seltzer is in the middle, they have a little white spot. Yep. And next up, after a few minutes, reactions settle down. To add it more, so we add more Alka-Seltzer. So we're gonna wait until the substance starts going down and the Alka-Seltzer is done with its physical change and it's done with its chemical change. And right now, I think this entire bottle is a heterogeneous substance, because it's no longer homo-hetero. homogeneous reaction. But it is definitely showing it. I'm going to look at here. Turn that on again. And tablets. Yeah. So I had a few more. So that one seems to be fizzling down. So I'm going to add one more. Now what else is here? We got the physical change of color. We got the tablets dissolving in the oil and the water, which is also a physical change. But the bubbling is the reaction of a chemical change within the two substances of the oil and the water. Now, oil and the water mix pretty well together, allowing the bubbles to become a bit more gelatinous and to bubble up as a chemical change as well in the beginning when we drop the food coloring within there. But that doesn't seem to be having much more reaction, so we're gonna drop, you know what? We're gonna drop the rest of them in there. So we're gonna have that one in there as well. See if that gives off more. You know what? Add one more thing of food coloring. Wow, and when I put some of the food coloring in there, it stays up because the bubbling from the Alka-Seltzer is keeping the remainder of the bubbles up there of the food color dye. Some are getting through because it's not that strong of a bubbling sensation yet, or a reactionary bubbling due to the chemical changes, but now it's starting to pick up. I'm gonna put the last amount of Alka-Seltzer in there, and let's see the rest. Oh, it got near the end there too. Starting to bubble a lot. Oh, here we go. Look at that right there. So some food coloring got stuck right there. And now the bubbles are coming up from, wow, that's really cool actually. Mom, come see this.
Hang on, but I got this on my lap.
So, these are like Orbeez. These bubbles have a bunch of, well, seltzer on them, as Alka-Seltzer says. Because I can see little tiny bubbles on these bubbles that are rising. Kind of like a fountain going over and over again. So the bubbling of the chemical reaction is giving these a physical change, which makes the bubbles into these kind of gelatinous type deals within the bottle, which is really interesting. I haven't seen this. Yeah, I'm gonna put some more Alka-Seltzer in there. I actually like that, it's cool. But, last one, if you want to store the container, last time's from Mercedes, you need to put a lid on container. Make sure the reaction is completely stopped as gas is released and release the buildup. Well, we don't want the gas to keep going, because if the gas keeps building up, that could possibly store a lot of gas that'll make this thing pop like a balloon and go over time. I'd say if, you know, an hypothesis, the bottle starts putting gas in it, like sodium or whatever, that would, the sodium was strong enough on the seltzer, and it kept building air and air and air, this thing would either explode, the cap would explode, or the bottle would explode. Kind of reminds me of another project I did with soda and Pop Rocks, which had sodium go up to a balloon and make the balloon rise from the sodium, giving the Pop Rocks giving the sodium to make the balloon float up. So I'm guessing that's the reaction that would happen. It'd be very kind of catastrophic. So let's put one more in there. Yeah, there it goes. Mom, here, before it's done, because I'm almost done with the video. But I'd say it's very successful, and with the terms I gave off, I think I did pretty well. Very nice. To be honest, I thought it was going to kind of be a fluke, but no, this is really interesting. But with that, I'd say that the video is done. Don't do that yet. I'm not done talking.
You just need a light and voila, lava lamp.
Yeah, that's pretty cool. Maybe I could figure out some sort of light to put under it, but yeah, the chemical change of the bubbling is occurring again. You got physical change of the color and the bubbles, and the sodium is constantly going. So there's no longer a homogeneous reaction, there's a heterogeneous reaction with all the substances come together, the water, the oil, the seltzer, and the dye to create a lava lamp. And I believe that's it.